Hi everyone, welcome to the class. Welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. So everybody let me know in the chat box if I am clearly visible and audible to all of you or not. Because today we are going to do NEST top previous year questions. It's good to hear your voice, right? But not always, right? Okay. So, everybody, we are going to start the session. Let me know if I am clearly visible and audible to you. So, I have picked up some really interesting questions for you, right? And let's start the session, okay? Yes. So, everybody, Namra, Nitika, Happy, Parvati, Divya, yes, I am here, I am here, I am here. So, I want to see you guys typing in the chat box, right? It's good to see people when they respond, right? So it's very, otherwise I'll start putting recorded classes only. If you're going to talk to each other only and you're not going to respond to the teacher, that is actually a disrespect of the teacher, right? If I am visible, then do let me know. I don't have some shaktiyan, I don't have some magics within me, right? That okay, I'll be able to understand what is going on in your head, right? Students, I'm a normal human being. I'm not a witch, right? Who knows that what is going on, right? I have some magic powers or something. No, nothing like that, right? So if you type only, then I'll be able to understand what is happening, right? If I'm visible and audible. And I want you guys to make this class interactive rather than not responding. And I see every time I come live on this channel, students are talking to each other. I don't know why, what is the problem, right? But that distracts other students as well, right? So let's not create that kind of community here. This is a study channel. Let's study here, right? We can, you if you want to talk, I am here to talk. You can talk to me, right? And this is JEE English. So type whatever you want to type in English, right? Okay? Yes. Okay, so let's start, let's start, let's start. Everybody, do you have your notebooks and your pen with you so that you can also solve the questions along with me, right? You can also solve the questions, ma'am, please, about, acha. Okay, this is not the right platform to talk about that, okay? Yes. Now, let us start with the first question on your screen. That is, consider the following reaction. This reaction is given to you. Now you have to tell what is this R and what is this S. So anybody in the chat box who will start doing this reaction along with me. Okay, tell me one thing. If you have SO3H electrophile, right? You have attacked SO3H here. So there is a reaction on benzene, that on benzene, when you have oleum, right, you have the formation of SO3H, right? After this, when you add molten NaOH and heat into it, you fuse the molten NaOH, then any idea what kind of sodium salt? This is also given to you, that some sodium salt is formed. So answer will be, what thing will be formed here? This is sodium phenoxide will be formed here, right? Yes, sodium phenoxide. This is called sodium phenoxide will be formed here. Now, this Q is the sodium phenoxide that you have. Now, you have two reaction. One is, chalo, I'll just copy paste this thing and I'll keep it here, right? Okay. So now there are two reactions. First reaction is when you have sodium phenoxide, right? You have to react this with which thing? CH3I, right? This is CH3I. Now, anybody in the chat box, can you tell me when you have one RONA and you have RI, can you tell me your RX? What is this reaction? What is the name of this reaction, everybody? What is the name of this reaction? Everybody, if you have RONA and you have RX, you have a alkoxide and you have one halide. Then when they react together, what is formed and what is the name of that reaction? That is in alcohol, phenols and ethers. This reaction is there in alcohol, phenols and ethers. Can you tell me the name here? Can you tell me the name here? Woods reaction? No, not Woods reaction. Woods reaction, beta. Woods reaction is when you have R, X here, plus you have Na, plus you have Rx. Then X, Na and X will leave and you will have the formation of RR. That is called Woods reaction. What is the name of this reaction? Where you form RONA reacts with Rx, that give rise to ROR. That is ether is formed here, right? Ether is formed. This reaction is called, I can't see even a single person typing what is the correct, what is the name of this reaction, right? What is the name of this reaction, students? Yes, this reaction is Williamson synthesis reaction. Very good, Divya, Ashutosh. This is called Williamson synthesis reaction, right? So that means the ether is going to form here. This is the R part. That means this is CH3, right? This is benzene and this is the R dash part. So you will have the formation of, what is the name of this compound? This is R because this is Q, right? Q on reaction with CH3I have the formation of R. Can you tell me what is the common name of this R? Can you tell me what is the common name of this R? No, it's not Itard's reaction here. Itard's reaction is when you have toluene here, that is this, you have chromyl chloride, then you have the formation of benzaldehyde. That is Itard's reaction. Okay, that is called Itard's reaction. You should know the naming reactions. They should be on your tips, right? So that means first one is, I forgot to, I forgot to have, this is not toluene. This will form, this is toluene, but it will form this OCH3, right? Because ROR is formed, no? So this ROR. So it will form methoxybenzene, right? It will form methoxybenzene. Methoxybenzene is here and here. That means these two are eliminated. Now let's see that Q on reaction of CO2 and H positive, what it will form, right? There is a reaction of CO2 and H positive here. So this is Q, right? On reaction of, this is Q on reaction of CO2 and H positive, what it will form, right? Okay, so what firstly we are going to do here, firstly this CO2 will get added here, right? Okay, this CO2 will get added here in the form of COH, right? Now what is going to happen, this is CO2 under very high pressure and heat, it is going to get added on this particular area. So I'll just write it here. Oh, this should be like this. Okay, it should be like this. Okay, that is formed now. Wait a minute. ONA is formed. Wait a minute, I just wrote the wrong Q here. ONA is formed here. This is Q, right? So Q on reaction with CO2, it is going to form, it is going to attach COH here, right? So it will be, this is benzene and here you will have O, right? After O, you will have the addition of COO, then you will have the addition of Na, right? This will be OH. You can also write it like this, right? You can also write it like this. I'll just tell you. So basically what you can do, there is one extra carbon here, that will be COONA, right? And this OH will be on this side, like this you will have, right? This is C6H4, that means this is the benzene ring that you have, right? This is one carbon. Here you will have COONA, right? Okay. And in this case, here you will have OH, right? After this, you will add H positive. This will be replaced by H. This is going to get formed. And can you tell me what is the name of this particular species? Anybody in the chat box, can you tell me what is the name of this species? 2-hydroxy benzoic acid, right? Because what you have is on second, this is 1, this is 2, 3, 4, 5, 6. Second, you have hydroxy. This is full benzoic acid. So answer will be 2-hydroxy benzoic acid will be S here. What you have to remember? What you have to remember here? Achha, can you tell me the name of this reaction? Let us see who tells me the name of this reaction. Who tells me the name? Who tells me the name of this reaction? It's a very, very famous reaction. Anybody? You have phenol, right? On phenol, you add any base. This will be ONA. After this reaction is same. Then you add CO2, right? Then you add KOH. Then you add H positive. What is that reaction? And you have the formation of salicylic acid, right? What we have formed here. Salicylic acid, what we have formed here. This reaction is called which reaction? Kolbe's reaction. Very good. This reaction is called Kolbe's reaction, right? So that was Williamson synthesis reaction. This is Williamson synthesis reaction. Okay? Williamson ether synthesis reaction. This is Kolbe's reaction. So from two naming reaction, they have asked you one question here, right? So that is how you are going to answer this, right? And I think that's it. Yeah. So answer will be E is the correct answer here. Next second question on your screen we have. Students, second question on your screen. Let us see who will answer me this. 2-phenyl, there is 2-phenyl propanamide. Second position you have phenyl and propanamide. So you have to draw this firstly. 2-phenyl propanamide. Propan means this, right? This amide, CONH2. 2-phenyl means here you will have phenyl. Okay. 2-phenyl propanamide. This is CH2. This is CH2. Okay. Now they are saying that this is reacted with Br2 aqueous NaOH. Now let us see who remembers this reaction. Br2 aqueous NaOH. It's a very, very famous reaction in amines. Very, very famous reaction in amines. Let's see who is able to answer this. What is the name of this reaction? What is the name of this reaction, students? Who is able to answer this? Let us see that. Right? You have to answer yourself also. In exam, I am not going to tell the answer sitting next to you. Right? You also have to like contribute to the session. Right? Only then that will remain in your head. Otherwise, there is no benefit of watching like a session just for the sake that I have watched it. Right? Then you are lying to yourself. Right? So you have to interact. Very good, Divya. That is Hofmann bromamide degradation. Right? That is Hofmann bromamide degradation. Right? In Hofmann bromamide degradation, you will have the CO will be eliminated, and in the answer what you will have this phenyl as it is, you will have this phenyl as it is, then this will be one CH2, then other CH2, then this will be NH2. This thing will be eliminated here. This CO will be eliminated, that will vanish in Hofmann bromamide degradation reaction. Okay. After this, let's see what they are saying. After this, they are saying that gives P on reaction with ethanoic anhydride gives Q. Now, if you see this here, 2-phenyl propanamide. Wait a minute. Achha, it is 2-phenyl, no? Then it will not be like this. This is becoming 3-phenyl. You have to answer for 2-phenyl. Right? That means it will be here. It will be here. Right? This will be here because they are talking about 1, 2, 3. 2-phenyl they are asking. Right? That means here the answer will be, when it will be eliminated, here the answer will be, you will have this benzene. Over this you will have one CH. This is CH3 and this is NH2. That thing will be formed. Right? After this, you are adding ethanoic anhydride. Now, ethanoic anhydride. This is basically, what is this called? Acetylation. Acetylation. That means the hydrogen on the nitrogen amine will be replaced by COCH3, right? So that will be replaced by COCH3, and you will have, in the end, you will have the preparation of, this is benzene, this is CH, this is CH3 as it is, this will be C, this will be CNH, this will be COCH3. Because COCH3, that is called acetylation. You can do this in presence of any acyl chloride or anhydride, right? So that acetylation will happen, and hence you will have the answer in the end, right? So here what thing will be formed? This will be CNH3. Achha, one more thing here. They are talking about ethanoic anhydride. Ethanoic anhydride doesn't mean that it will undergo acetylation. We have to focus on this thing as well, right? Can you tell me what is ethanoic anhydride? Anybody? What is ethanoic anhydride? First, you should know how to make the structure of anhydride, right? Anhydride, firstly, you should know. Let us make anhydride, right? Ethanoic anhydride means you are doing two ethanoics. So it will be CH3COOH. This will be COOH. This is CH3. This is ethanoic. And now, when you take out water from here, right, then it will be CH3, then CO, then O, then CO, CH3. That means, can I say it will be CH3? Yes. CH3CO twice O, right? That is ethanoic anhydride. Now, this portion that you can see here, this is acetyl group. That means acetylation will occur. If let's say here you had C2H5O, CO, then you would add C2H5CO. But here they are telling you to add ethanoic, so it will be acetyl group only. So that means what we did before was the correct thing, right? So that means this was the correct thing. So you can easily add it here. This is CH, this is NHCOCH3 that is added, and this will be CH3. So that is your final answer, right? This is P, right? And here they are saying it will lead to the formation of Q. So this is Q. So that is Q what we have, right? Let us see what is that Q. Okay. Hi Pratyush, afternoon ma'am. Can you please bring a video in which there is a detailed chemistry planner for JEE 2027? Okay Pratyush, done. Okay, I'll bring the roadmap for you. Don't worry, like full proper. Like in chemistry, what we will do in detail, like everything, I'll plan for you. Okay, don't worry. Yes, Pratyush, I'll do that. Now, let us see Q. What is Q? This is Q. So, answer will be A is the correct answer. Is that clear? Answer will be A is the correct answer here. Right? Let us move to the third question here. Right? That is, consider the following compounds. So, these compounds are given to you P, Q, R, S. The correct order of rate of acid catalyzed dehydration. Acid catalyzed dehydration. So you have to tell the rate. Whenever they ask you the rate of any reaction, what is the first thing that you need to focus on? Whenever any reaction I am talking about, whenever they ask you the rate of reaction of any reaction, the first thing that you see is the intermediate here. So anybody who can tell me the intermediate which is formed here? Anybody who can tell me the intermediate which is formed here? The intermediate which is formed here. Any one of you? The intermediate which is formed here. Any one of you? Any idea also? Any idea also? Any idea also? Yes, everybody? Yes, everybody? Any idea? Any idea? So here we have intermediate is carbocation. Okay, intermediate is carbocation. So what we will look for, that which carbocation is maximum stable. Now, if you see this here, firstly tell me one thing, how you look for the stability of carbocation. How you tell the stability of carbocation? Stability of carbocation. How you tell the stability of carbocation? Carbocation is a positive species, right? You can consider it as money, right? Now, when someone is poor, electron deficient, you give them money, they will be happy. That means to make carbocation stable, electron donation is needed, right? If you take away electron, it is already poor, then it will be very unstable, right? That means it will move towards instability. That means what you need to have good donating groups. Only then it will be stable. For carbanion, it is completely opposite. Carbanion is like you have stress, right? So whenever you give someone stress, what will happen? They will be stable or unstable. When you give someone stress, right? If I keep giving you stress, right? I'm like, okay, you have not done this, you should do this, but I'm doing nothing for you. I'm not going live here teaching you, all I'm giving you is stress, right? That means it will make you sad. Ma'am, if you're talking that do something in your JEE 2026 or 2027, then you also have to plan some sessions. Ma'am, if you're talking about NEST, then you also have to plan some sessions, right? So if I am taking away stress, that means if I am teaching you, right, and guiding you, then you will be more stable, right? So if someone gives you stress, you will be unstable. Someone takes away stress, you will be stable, right? That means now at this point, all I need is intermediate is carbocation. So that means I need good electron donating groups, right? If I have good electron donating groups, automatically, right, thing will be sorted here, right? From where I can have dehydration from this side, this side, this side, and this side. That means here you will have a positive charge after loss of OH negative, positive here, and positive here, right? This thing will happen in reality. What will happen? This OH negative will leave, right? This will be dehydrated, this will be dehydrated, right? This will be dehydrated. Carbocation formation we are doing now, right? OH will leave. Right? Now you tell me which is a more stable carbocation. If you see, this is the differentiating point you have to see, right? This we have plus I effect of CH3. Here you have no effect. There is no differentiating effect out of others. This COCH3, if you see it, no, this is OCH3. This is OCH3. That means this oxygen is single bonded. That means it is going to donate the electron. It is going to show plus M effect here, right? It is going to show plus M effect, and it is also going to show minus I effect, but plus M is more dominating here, right? Plus M is more dominating here as compared to minus I here, right? Next is this thing is taking away electrons from you by minus M effect, right? By minus M effect, and it is also showing minus I effect. Now, can you see which is making the carbocation most stable is a plus M effect, because mesomeric effect is more dominating. So R will be maximum stable, right? Then you will have P, which is showing you inductive effect. Then you will have Q, which is not showing you any effect. In the end, most unstable will be NO2, that is S, which is having minus M and minus I effect, that is electron withdrawing group, making it very unstable for you. So answer is going to be B is the correct answer here, right? So we will put B is the correct answer here. That is clear to everybody or not, right? B is the acid catalyzed dehydration. The intermediate form is typically a carbocation. Very good, right? Okay, so answer will be B is the correct answer here. Now let us talk about the next questions here. That is the amino acid whose aqueous solution turns red litmus blue. Now you have to tell me this, you have studied in like lower classes also. Red litmus blue. Red litmus blue. That is an acidic medium or basic medium they are talking about. Acidic medium will turn red litmus blue or basic will turn red litmus blue. Which will turn red litmus blue? Which will turn red litmus blue? Let us see that here. Right, I am waiting for your chats, for your comments in the chat box. So red litmus blue is turned by acidic medium. Sorry, acidic, I'm writing basic medium, right? B for blue, B for basic. So blue is turned when it has basic medium, right? Okay, now let us see. Yes, basic medium. You have to, that means you have to tell which amino acid turns this, that means which is maximum basic in nature. Now, basicity is directly proportional to electron availability, right? More the availability of electron, or you can say directly proportional to electron donating group, inversely to electron withdrawing group. Now, you have to see where the electrons are most available so that they can donate its electrons to create basicity, right? Because bases are electron rich compounds, right? This you have seen in Lewis acids and Lewis bases. Bases are Lewis bases are electron rich and Lewis acids are electron deficient, right? Now we will see what is the differentiating. This is same, this is same, this is same, this is same. That means this thing is same. The differentiating part is this part, right? That means I'll just write down the differentiating part here. Right, I'll just write down the differentiating part here. This differentiating part is this thing. Here, this is the differentiating part. This is the differentiating part. This is the differentiating part. And if I want to look for one NH2 here, this NH2 is present here, right? This NH2 is present. These electrons are present. These electrons are present. But if you see, this are same everywhere. I have to look for the differentiating factor which can tell me which is more basic. So here if you see, these electrons are under conjugation, right? That means these electrons are not completely available for the donation. That means this will be a weak acid, a weak base, right? Let's see this. Here also you have two lone pairs, but both are involved in the, like at least one of them is involved in the donation with the benzene ring, right? It is donating to the benzene ring. And moreover, oxygen is more electron negative than nitrogen. So oxygen will be like, I have lone pairs, but because I am more electronegative, I don't have the capacity more than nitrogen to donate, right? Oxygen is more clever. Oxygen is like, I don't want to donate the electron. Nitrogen will be like, I am better than oxygen, I can donate the electron. So oxygen is already ruled out. Here also oxygen is already ruled out. See, if you see this here, this is NH2, this is OH. This oxygen here is ruled out, reason being because it is more electronegative. But in this case, you have this NO2, this is fully available. Though in this case, you had two lone pairs. But here, oxygen is clever. It doesn't want to give its electrons. Nitrogen can still donate. That's why this is most basic in nature. So answer will be C is the correct answer. Tell me students, is that clear how C will be the correct answer? Is that clear to everybody? What are the different things you will see in one question, right? The best thing about these kind of questions is that you don't have to do calculations, right? Directly you can answer these kind of questions, right? Okay. Next, let us see, that is the correct order of reactivity of the metal rubidium, barium, molybdenum and cerium with water. Okay. Reactivity of metal with water. Now, firstly, you have to know one thing, that alkali metals maximum, then you have alkaline earth metals, then you have alkaline earth metals, alkaline earth metals. Then after that, what you have? After that, what you have is the F, or you can say F orbital, or you can say F block elements, right? In the end, you will have transition elements, which will have least reactivity with water. Now, if you see this, in this case, you have rubidium, then it will be barium, then it will be cerium, last will be molybdenum. That means this is going to be the order: rubidium, barium, cerium, molybdenum. So answer will be A is the correct answer. Okay, direct. It is a fact-based question. Okay, it's a fact-based question. So answer is going to be A is the correct answer. Let's go for the next question here. I think this you can answer easily. Let's see who is going to answer this. Let's see who is going to answer this. Right? Very good, Pratyush. That was in class 10th also. Yeah. Metals, non-metals, isn't it? But as you go to higher classes, you forget about basic things. That's why they sometimes ask you very purely basic things, that if you remember that also. While studying higher, then you also forget about lower things, right, that you have studied in your basic of 10th or 9th class, right, that I have seen among students. They know how to solve questions of JEE, but they don't know how to solve easy questions, right? Okay. Consider the coordination compound, this, and this, denoted respectively. These four coordination compounds, the correct order of wavelength here. Now, we know that energy is inversely proportional to lambda, right? That means energy is in spectrochemical series. If you see NH3, here you have 5 NH3, right? 6 NH3, that is going to have maximum. I firstly write the order of energy. If this is P, this is Q, this is R, and this is S, then maximum energy will be of P. Then you will have, maximum will not be of P, maximum will be of S. Why? Because CN is more strong ligand as compared to NH3, right? So maximum will be S, then you will have P, then you will have, out of these two, Cl is a weaker ligand as compared to water. So here it will be R, then it will be Q. And lambda will be opposite of it. Lambda will be S, P, R, Q. So Q is going to have maximum, then you will have R, then P, then S. So answer will be B is the correct answer. What you have to remember here, that Cn is maximum. Spectrochemical series you should remember. Out of spectrochemical series, Cn, then you have NH3 if you talk about these ligands, then you have water, then you have Cl. From this, you can directly answer this question. That is going to be B is the correct answer. Is there any problem in this question, students? Is there any problem in this question? Everybody, any problem here? If so, then let me know in the chat box, right? Now, let us move towards the next one here. It is the number of geometrical isomers possible for a complex this is. Now, geometrical isomers. See, geometrical isomers, if you talk about a complex which is having coordination number 6, the geometrical isomer, if you talk about a double bond, then the answer would have been this is 1, this is 2, this is 3, this is 4, right? In double bond, right, this 1 should not be equals to 2, 3 should not be equals to 4. That shows geometrical isomerism, right? In cis, 2 same groups are together, and in trans, 2 same groups are opposite. For example, this is called trans, and this will be cis. This will be cis. Okay. Now, let us talk about if the coordination number is, if you are talking about coordination compounds, right? If you say coordination number is 6, coordination 6 number means you have this kind of geometry, right? This means you have this kind of geometry where you need to see that if you have two same compounds, two same groups that are opposite, then that will be trans. Okay, let's see the combinations that we can have, right? Let's see the combinations that we can have. We have these three things. So first possibility of geometrical isomerism is that you have NH3 as trans. Second possibility is that you have water, because they are asking you geometrical isomerism, how many number you have. Water can be trans. Third possibility is because, right, then third possibility is this one, where you can have Cl and Cl as trans, right? Okay, now this is what you have is the NH3, all of these, right? Now, if you see this, one possibility is you have this water, H2, right? And H2 here, right? And this is Cl and Cl. Other possibility is you have Cl, and you have NH3 here, right? Third possibility is that you have Cl is same, then you have water, cis, and you have NH3 as cis. So these are the three possibilities of cis-trans isomerism, right? These are the three possibilities of cis-trans isomerism. If I take one as trans, other two as cis, this is in cis, right? Now, I'll draw the same thing here, one more thing here. Let's say I draw two as trans. Let's say I draw H2O, right? Then Cl as trans. If two are trans, third will automatically be trans. That means the next possibility is that all of them are in the trans state, right? This is the next possibility, that all of them are in the trans state. Is there any other possibility? First is keep one at trans, others are at cis, right? This is the three possibilities. Next is keep two at trans. If you keep two at trans, this and this at trans, third will automatically be at trans. So that means when you keep two at trans, third is also at trans. So there is no more possibility of cis trans. Can you keep all of them in cis? If you have this thing, can you keep all of them in cis? So this will be H2O, right? Can we keep all of them in cis? H2O, this is Cl, this is NH3, this is NH3, right? Either you can keep all of them as the cis, right? Okay, so these are the different possibilities that you can have here, right? So basically what we are doing here, I'll just show you that, right? Let's make the first one here. That is when you have two on the same side. I need to have different color of atom, right? Wait a minute, guys. Okay, so that you can also understand what is happening here, right? There is no benefit of cramming things, right? Sure. Let us see that. One green I have taken, right? One green I have taken, one red I have taken, one white I have taken. So can you see this here? At this point, what you will see, all of them are in trans. White and white is opposite, green and green is opposite, red and red is opposite. So all of them are in the trans position. Okay, all of them are in the trans position. These are opposite, these two are opposite, and these two are opposite. So all of them are in the trans position. We are talking about this position where all of them are in the trans position. Okay, this is this kind of thing that I am talking about, right? Next is, let's say I want to keep only one in the trans, other should be in the cis side. Okay, other should be in the cis side. That means this is what we are talking about, right? If you keep, let's say, NH3 in trans, other two are on the cis side, right? If I keep H2 on the trans, other two are on the cis side. If I keep Cl on the trans, other two are on the cis side. Okay, so that means we are talking about these three. 3 plus 1. Now let's talk about the last one where two are in trans, right? Where where all of them are in cis. Okay, for that what you need to have, this is important, right? We really need to see if that is possible, right? This thing, if you see, this is in cis next to each other, this is in cis next to each other, this is in cis next to each other, right? So all of them are in the cis, right? So that's how you have the cis one, right? So that's how you have the cis one. So that means, right, they are asking you number of geometrical isomer possible for this complex here. That will be 1, 2, 3, 4, 5 is the correct answer, right? I'll just, this is not 3, this will be 5. Okay, so 5 will be the correct answer. If they ask you only cis trans, that means where you have cis also, trans also, then the answer would be 3, right? Okay, now next is the element C borium with atomic number 106, right? If you have atomic number 106, has the electronic configuration of this, right? Okay, then the element with atomic number 114, that means you have to add 8 electrons here, right? You have to add 8 electrons here. So that means in this you will add 8 electrons. This is 5F14, 6D4, 6D4, 7S2. So you will add firstly how many electrons? 106 plus 8 electrons will give you 114, right? So 6 electrons you will add here. This will become 6D10, and out of that 2 electrons you will add to this side. That means this will be the case here, right? That will be the electronic configuration of 114, right? What I did, I added plus 6 electrons here to make it 10, right? Because 10 maximum I can make it. And I added 7p2. That means total I added 8 electrons here, right? Now they are asking you this is belonging to which group? But can you see, if you remember that, how you identify the group? Okay, first you have to identify the largest number. First you identify the period. Anybody, the period? Period is the largest number of principal quantum number, right? That is 7, right? So answer will be, it will be 7th period. Answer will be, bacha, it will be 7th period, right? Next question is, how to identify the block? First, you will have to identify the block. What is the block? Block is, if you see last electron, I am filling in P, right? Because I am filling 10, then 2, I am filling then 1, 2. If you have one more, if I am talking about 115, I would have written here 3, right? That means last electron is in P, so answer will be P block, right? Then what is the group? Now anybody who will tell me the group? If you talk about the group here, one thing you should know about P block periodic table is that this is S, this is D, this is P. Okay, this is P. Okay, this is P. Now, this is P. Here you have 10. Here you have 2 groups before it. Here you have 10 groups before it. That means for P, you will have to add P electrons in P plus 12, right? So what we will do, 12 plus electrons in P electrons you can just directly write here, right? That is 12 plus 2, that is 14. So answer will be 14 here. So answer will be 14 here. So you can just directly write here that answer will be 14. That is B is the correct answer. Is that clear to everybody? B is the correct answer, everyone. Is that clear? Right? Okay. So answer will be group number 14, right? B is the correct answer here. right? That means it belongs to carbon family. It belongs to carbon family. It belongs to carbon family, right? Okay. Shall we move with the next question? How to manage pre-boards? Pratyush, I have already made a video on that, right? I have already made a video on how to manage your boards. So you can just go and watch that video. That will really, really help you. Okay. Is that clear, students? Next one is, let's talk about the next one, that is cobalt 3 chloride on reaction with ammonia yields an octahedral compound. Octahedral compound means coordination number is 6. They are telling you that coordination number is going to be 6. Right? Cobalt 3 chloride on reaction with ammonia 3 chloride. Right? That means chromium is existing in plus 3. Right? Chlorine is minus 1. So here formula will be ClCr1 Cl3. This is reacted with ammonia. This thing is reacted with ammonia. And you are getting a compound which is having, you're getting a compound here, right? Okay, which is having coordination number 6, which is X, which exists in 2 isomeric forms, one color green, other color violet. Further, conductivity studies X as a solution reveal the presence of 1:1. That means outside the bracket, you have just one chlorine, right? You have just one chlorine outside the bracket, because then only this will form one ion, this will form one ion, ratio will be 1:1, right? So here, that means other two chlorines are inside. That means how much ammonia you need? That means 4 ammonia. That means here 4 mole. They can also ask you how much mole of ammonia is used. 4 mole of ammonia is used. This is our compound. Now, this compound, we know that this gives cis and trans, right? I'll just show you how cis and trans is formed here. This is chromium 1, 2, 3, 4, 5, 6. This is chromium 1, 2, 3, 4, 5, 6. If you have trans, that means NH3 are opposite. Then you have NH3, then Cl and Cl. This is trans. And what is this? This is when you have NH3, right? Cl, NH3. Okay, so that is cis. Now, because it has cis and trans, that is the reason it is going to have 2 isomers here. And what you will see that in the cis form, right, it appears violet, and the trans form, that will appear green. And that is the reason you can say that answer is going to be, you will have cobalt Cl3 NH4 thrice, or we can also ask you the compound also, that will be NH3 4 Cl2 Cl. That will be the compound that you will have. So answer is going to be C is the correct answer here. Right? Clear everybody? C is going to be the correct answer here. Right? Okay. Moving towards the next question here. That is very interesting one related to a simple reduction potential and oxidation potential. This is right. Let us see that. They are saying that vanadium can exhibit different oxidation state 2, 3, 4, 5 in solution. Right. Standard reduction potentials of all of these are given to us. Understand that in a reduction potential, oxidation number decreases. Oxidation number decreases in a reduction potential, right? So when we are talking about the reduction potential, oxidation number is decreasing here, and that is 3 to 2, 4 to 3, 5 to 4. This is decreasing, right? So you have 3 reduction potentials. A solution of this in dilute HCl. Can you firstly tell me in this see, this is NH4, this is NH4 thrice VO4, this is 1. That means it would have been NH4 is in plus state, and VO4, it is in 3 negative state, because only after cross multiplication they will form this compound, right? That means, can I say that here, if you have to see the oxidation state of vanadium, that will be x minus 8 is equals to minus 3, x is going to be plus 5. That is going to be the oxidation state. Okay, x is going to be plus 5 here. Now, when you have x is equals to plus 5, that means in this solution, right, vanadium is existing in plus 5 state. In dilute, HCl is treated with tin. It is treated with tin, right? Which reduction potential is this much? The oxidation state of vanadium is this. Okay. See, if you have to reduce it to vanadium 4 positive, then to vanadium 3 positive, then it can also exist in vanadium 2 positive. You need to have a good reducing agent, right? If you want to reduce vanadium 5 to 4 to 3 to 2, then you need to have that kind of reducing agent that can cause the reduction of these things, right? If I want to decrease the oxidation number here, I need to have a good reducing agent that will reduce the oxidation numbers here. Now, if I want to reduce the oxidation number, I want to have an reducing agent. In that reducing agent, the reduction potential should be more, right? That is a good reducing agent which can reduce you. That means its reduction potential is more than you. That means I need to have, that means this should be more. This has to be more. Okay, this has to be more. Okay, its reduction potential is given to be minus 0.14, right? Vanadium. Wait a minute. Reduction, we are decreasing reduction potential. This is for this. No. It made the wrong statement here. Yes. If I want to, wait a minute, let me just clarify that. If I want to reduce this to this, that means the reduction potential of this thing should be more. It should be more. This should be more. This should be more. Only then this reduction is possible, right? Only then this reduction is possible if its reduction potential is more, right? The one which has more reduction potential will cause more reduction, right? Otherwise, the reduction of this will occur, right? So this is minus 0.14. This is about 3 to 2. This is 3 to 2. This is for, wrong. This is for 3 to 2. This is for 4 to 3. This is for 5 to 4. Okay. So you need to see the one which has more reduction potential as compared to this. Now we know that this minus 0.14 is less as compared to this. That means it has more reduction potential. So this will definitely happen, right? This will happen. Now for 4 positive to 3 positive, 0.337, which is more than minus 0.14, this will also happen. But if you talk about this thing, 3 positive to 2 positive, right? Now, in this case, reduction potential is minus 0.25, which is less as compared to minus 1.4. In the number line, here you have minus 1.4 and here you have minus 0.25, right? That means this is less. So here in this case, it is not possible. That means the final oxidation state of vanadium is going to be plus 3. After this, reduction is not possible with the tin. Okay. After this, reduction is not possible with the tin. Okay. Yes. Harsha definitely will take. Ma'am, Sigma batch is only for dropper or class 12. That is for both droppers and class 12. Right. The timings will be in the evening only. Just for the holidays, the timing is in the morning. Right. Otherwise, the timing is going to change as the holidays, like you're over with the holidays. Right. I think within 5-6 days only the timings will change. Right. Okay. Yes. Now, let us see the next one here. This is done, right? This is done. Next question here, students. Next question on your screen we have, consider n moles of ideal gas undergoing a cyclic process. That is this to this, this to this, this to this, as shown below. Now they are asking you the correct option here. You have to tell the correct option in these processes, right? Okay, students, you have to tell the correct answer in these processes. If you see the work done in the process of x to y, y to z, y to z, can you firstly tell me y to z is the isothermal adiabatic, what kind of process? They are saying the work done is 0. We know that here in this case, pressure is also changing, temperature is also changing, right? Pressure is changing or not? Y to z, no? Work done in the process of y to z. Pressure is also changing, right? That is also changing. I think there is some I think the question is wrong. This should be z to x. This should be z to x. Okay, this should be z to x. It should be written here z to x. Okay. So here if I see z to x, right? Firstly, tell me about z to x, right? Is this isobaric? Is this isochoric? The pressure in z to x is constant, right? So that is going to be a isobaric process. In an isobaric process, work done is equals to minus P delta V, right? Because it is not equal to 0 because we are not talking about the change in pressure, right? So it cannot be equals to 0. So the first statement will be false. First statement is not true, right? Next is the work done in the process of y to z, because they two statements, they can't ask work done of y to z, no? Y to z, the work done of y to z. Can you see this? Y to z, temperature and pressure both are changing. Now they are saying it is nRT2 ln of P2. Can you tell me what is this work done equation for? nRT, natural log of P2 by P3, pressure final by initial. This is the work done for isothermal. But Y to Z is not isothermal. This is not isothermal. This is not isothermal. So the work done cannot be this thing. So that means this is also the incorrect statement. Okay? They are telling you about the work done here. Work done is this, which is for isothermal process, right? But this Y to Z is not isothermal, right? Their temperature is not constant. So this is also the wrong statement. That is A and B both are the wrong statement. Okay, let's see the third one. In the process Z to X, Z to X is this. Delta U is positive, delta H is 0. Delta U is positive. The first thing is, in this case, temperature is decreasing. Can't you see? Temperature is decreasing. When temperature decreases, delta U also decreases. That means U final is less than U initial. That means delta U is negative, right? Here they are saying delta U is positive, which will be negative. So answer means this is also the false statement, right? Next is in the process of x to y. You have from x to y. X to y is this. Delta U is 0. Delta U 0 means x to y. You have x to y, this thing. Delta U is 0, delta x is 0. See x to y, can you see x to y is a isothermal process. Isothermal process. That means definitely delta U is equals to 0 because delta T is also 0. Right? Now, next is because delta T, I'll just write it here, right? Because delta T is also 0, that means delta U will be equals to 0. Delta H is positive. If you see this here, pressure is x to y, pressure is constant here. X to y it is, no? X to y. X to y means you have to go this way. Pressure is decreasing. When pressure is decreasing, right? When you're decreasing means it is expansion, right? Pressure is decreasing, that means you're doing expansion. And in expansion, delta H will be positive. That means this is the correct answer. This is the correct statement. So D is the correct statement in the end, right? D will be the correct statement. Answer will be D is the correct answer here, right? Okay. Yes, everybody. Is that clear? Sure. Let's talk about the next one. Let's talk about the next question here. That is based on in H3PO2 and H3PO3, the numbers of pH bonds are respectively. You have to see the pH bonds here. Ouch. Okay. A, B, C, D. Let's see, this is A, B, C, D. Now let's see H3PO3, the number of pH bonds here. Right? Okay. So I'll just correct it. Right? pH bonds here. Anybody in the chat box? This is A, this is B, this is C, this is D. Anybody the pH bonds here? For that, you definitely need to draw the phosphox or oxaloacids, right? So if you see H, first I'll draw for H3PO4. H3, that is not there, but you should know. Then it is H3PO3. Then it is H3PO2. Now, always remember, whenever you are drawing the phosphoxylacids, phosphorus will have a double bond O, then 3 bonds. Phosphorus double bond O, then you will have 3 bonds. Phosphorus double bond O, then you will have 3 bonds. Okay. Now, in this case, you have one phosphorus, subtract one phosphorus and one oxygen here. You are left with H3O3. That means you will have OH, OH, OH here. This is H3PO4 only, right? That means this is the correct structure. Let's subtract phosphorus and oxygen from here. We will be left with H3 and O is 2, right? That means 2 OH you will have and 1 H you will have, right? In this case, when you subtract P and O here, you will have 3 hydrogen and 1 oxygen. That means 2H, 2OH and 2H and 1 OH here, right? So they are asking you about which thing? H3PO2. H3PO2 has 2 OH bonds. This has 2 pH bond. This has 1 pH bond. So answer will be 2, 1. So answer is C is the correct answer here. Okay, C is the correct. That is a very basic question, right? You should definitely be able to answer this. Right? Okay. Yes. Yes, I am drawing there only. Extra I have. So let's see this here as well. Right? I'll just mark A, B, C, D here. Right? So that you can also answer. Right? This is A, this is B, this is C, this is D. This is a reaction from P block. Right? It's a reaction question from P block. Let us see how to answer that. Okay. Okay. Yes. Very good. Very good. Okay. Now, oxidation of NaBH4. When you oxidize NaBH4, you have NaBH4. NaBH4. Right? With iodine, if you oxidize it with iodine, results in evolution of a colorless gas. Can you tell me what is that colorless gas? That is diborane, right? That is diborane. Okay. Now this is X. Along with the formation of NaI is formed and H2 gas is formed. Now they are saying 3 moles of X. This is X, okay? This is X that is formed, and 3 moles of this X reacts with 6 moles of NH3. 6 moles of NH3 to form an intermediate which upon heating results in Y accompanied by hydrogen gas. Now, whenever you react diborane with NH3, what will happen? You will have a very, very interesting compound that is B3N3H3. Okay, B3N3H3. Okay, let's see this here. How? What is this? Can you tell me what is the name of this compound? This is diborane. What is this? This is organic benzene, right? Instead of carbon, you have one nitrogen. One nitrogen here, one nitrogen. Achha, achha. One nitrogen here, right? One nitrogen here, then one nitrogen here, right? So what you will have here, this is N, this is N, this is N, right? This will be one hydrogen here, right? One hydrogen here, one hydrogen here, right? There will be boron also. No, why I forgot to draw boron. So let me just draw boron here, right? So this will be B, B, and B, right? Now, if you see, that is making the full compound here, right? Okay. So answer is going to be C is the correct answer here. C is the correct answer here, right? Okay. Inorganic benzene is formed, right? Everybody, inorganic benzene is formed, or borazole. Very good. Or borazole is formed, right? Then the correct order of acidity is, now you have to tell the order of acidity here. This is A, B, C, D, right? Order of acidity you have to tell here. So for order of acidity, what you have to do, first you have to take away one hydrogen from here. So if you talk about CH2, that is nothing but that is this thing, right? If you talk about H2O2, that is nothing but that is this thing, right? If you talk about HCN, that is HC triple bond N, right? If you talk about HSCN, that is this thing, right? You can just directly write it here. Now, if you take out one hydrogen, this will be C triple bond. This is CH. This is negative. This will be OOH, and this is negative. This will be C triple bond N, and this is negative. This will be SCN, and this will be negative. Now, out of this, the acidic character, if you see, is going to be maximum for this SCN because this is a bigger molecule. So first will be HSCN is going to have the maximum acidic character because it is a bigger molecule. This and this are already eliminated. Now, if you talk about, ma'am, here you have oxygen, it has negative, ma'am, that is very stable. No, right? Because electronegativity is also dominated. If you have carbon negative with a single bond and oxygen negative with a single bond, then I would say oxygen is more stable, then that would have been more acidic. But in this case, you have triple bond here, that means here this is sp, right? Here this is also sp, right? That means out of these two, something will be more stable. And if you see this here, this is sp, this is sp. If you see this here, this sp is going to be more stable. This is also bonded to cn here, so this is going to be more stable. So then answer will be HCN, and here it is HCN. Now the next is that H2O2 or C2H2 is more stable. Then students will go for not sp, right? Because this is bonded to C only. Rather, this oxygen here is more electronegative because this is like oxygen is more electric as compared to carbon. Here, this is more dominating because it is attached to nitrogen also. So answer is going to be A is the correct answer here. After this, you will have H2O2. Then you will have C2H2 here. So answer is going to be A is the correct answer here. Right? Okay. Now, next question. It may seem a very, very big question, but it's not a difficult one. It's an easy question. Let's try to solve it. Okay? Let's try to solve it. Let's try to solve it. Okay? Wait a minute, students. Just give me a second. this. Okay, now let's see this here. Let's see this question here. Consider a chemical reaction. You have to consider one chemical reaction, P to Q, being carried out in two different vessels. Okay, so P to Q is a reaction. I'm just writing it here. P to this is Q. This is the reaction that is carried out in two vessels. So what I'll do, I'll just draw two vessels here. This is P2Q. This is P2Q. Right? This is also P2Q. It is being carried out in P2Q. Right? In two vessels, different vessels X and Y, X with 1 liter of P in each of them. That means this vessel is X, this vessel is Y, and here also the volume is 1 liter. Here also the volume is 1 liter of P is initially there, right? Then they are saying that I started with 1 mole of P in X and 2 mole of P in Y. That means 1 mole of P in X. Here you have 1 mole of P, 1 mole of P. Here you have 2 mole of P, 2 mole of P. Okay. Further, P is added continuously to both vessels at the rate of 1 mole per vessel during the first 2 seconds only. So they are saying that in first 2 seconds, 1 mole per second is being deteriorated. That means it is being taken out. Right? Further, P is added continuously to both the vessels at the rate of 1 mole per second during the first 2 seconds. It is observed that P remains constant at the initial value in both the vessels during the addition. So what they are saying is that in next 2 seconds you are adding, here the time is 2 seconds and you have added 2 mole. So that this has become 3 mole. Okay, this has become 3 mole. But you have also observed, and here also what you did, here also in 2 seconds, in next 2 seconds, you have added 2 mole and this has become 4 mole. Right? In next 2 seconds, you are adding 1 second correspond to 1 mole. So 2 seconds corresponds to 2 mole. For 2 seconds, the rate is 1 mole per second. That means 2 seconds will add 2 moles. So we have added for next 2 seconds, you have added 2 moles. This is 3 mole, this is 4 mole. Now it's a very, very interesting thing. They are saying that it is observed that P remains constant at the initial value in both the vessels during the addition. That means as you are adding, the reaction is also taking place. That means I have a beaker, I am adding something, but this product is also getting reacted, right? So the same time when you were adding this, the same time what was happening within this 2 seconds only, 2 moles were deteriorating. Only then in the end you had 1 mole here, and here also you had 2 moles were deteriorating. This means 2 mole was there, right? In that 2 seconds, what has happened? You have added 2 moles because they are giving you in 2 seconds, 2 moles will be added because the rate is 1 mole per second, right? And they are also saying that it will be same as the initial value. Why? Because 2 moles you are adding and 2 moles are getting consumed in 2 seconds. And in this case, what is happening? It should be same as the initial value. That means you are subtracting 2 here, right? In those 2 seconds, that means 2 moles you are left with. That means 2 moles you are left with. 2 moles you are left with, and this will be 2 mole here is formed, right? Till here, if this is clear, let me know. 2 moles you have already consumed. The amount that is consumed here will be formed here, right? So 2 moles, there were, for example, 2 moles were initially, 2 moles you are adding. At the same time, let's say this is a beaker, right? You had 2 moles here, right? You are adding 2 more moles here, but within that time, this 2 moles has already been consumed. That means within that time, this 2 mole has already been consumed. Got it? So this is what is happening here. So that means in the end, we are left with 2 moles here and 1 mole here. Now they are asking you, it's just to confuse you, okay? They are asking the volume change due to addition of P is neglected. Volume change we are not even thinking. Instantaneous mixing is assumed. The concentration ratio of P by Q in the vessel Y at time 3 seconds. So in the third second, what will happen? See, in the third second also, you will add one, isn't it? This is 2 mole, this is 1 mole, right? They're asking you P by Q. So here, wait a minute. P by Q, the concentration ratio. In next third second, right? So that means in 2 seconds, 2 moles are being consumed. So when I will add one more here, what will happen here? When I'm adding one more mole, right? Again, one more mole is being consumed. And here it is being added only, right? So that means in the third second, it should be 1 by 3. Yes. Okay. So that means what we are doing here, see this here, you are adding in the third second also. What is happening in this case? What is happening? You have a beaker, you add 1 mole or 2 mole. Let's see, in 1 second, you are adding 1 mole. And in that 1 second, 1 mole is being consumed. So when you're adding 1 mole here, 1 mole is also being reacted. This you're adding externally, this is happening in the reaction. If 1 mole is being consumed here, that will form the product. That means 1 mole will be added in the time 3 seconds. This is time is equals to 3 seconds. In this case, what will happen? 2 plus 1, that means 3 mole of Q you will have. So answer will be P by Q is equals to 1 by 3. Okay, so answer will be 1 mole you are adding, right? 1 is being subtracted here, so that is going to be 1 by 3 here, right? And in fact, in the third case, they are saying nothing you are adding, right? That's why we are not adding anything here. We are just subtracting, because when time is equals to 3 seconds, the same amount will be subtracted, no? That is 1 mole. So subtract 1 mole, you will have what amount left? 1 mole you will be left with. And here we will be left with 3 moles. So answer will be 1 by 3. The answer is going to be A. This is A, B, C, D. A is the correct answer here. Okay. Next question. I think I am teaching myself only. I can clearly see how beautifully you react, right? Then you say, ma'am, please take classes, ma'am. We are not going to respond, ma'am, but you take classes, right? Very beautifully you guys are, giving importance and respecting the teacher. Hats off to you guys. Hats off. Knowledge, when it is, they say that knowledge, right, should not be free. When it is provided free, this happens, right? There is no acknowledgement for the knowledge. That I can see on your faces and on your chats as well, right? Okay. So the internal, but my duty is to teach, so I'll teach. But your replies are next level, and hats off to you. I would have been at your situation, I would never have done this to any teacher, but thanks for that, right? Just showed me that this teaching for free, right, is not a good thing. You just showed me that. Thank you for that. Okay. So the internal energy per mole of an ideal gas is denoted by E ideal. The same for a real gas obeying van der Waals equation is E real. So internal energy they are telling you by E. For ideal gas it is E ideal, and for real gas it is E real. Now you should know that internal energy is equal to the potential energy, right? Okay. Is equals to the kinetic energy. But in ideal gas, we assume that there is no potential energy, right? Okay. So, but in real gases, we assume that there is potential energy as well. Now, assuming the average kinetic energy of the molecules of two gases at the same temperature to be equal, they are saying the kinetic energy of two molecules are equal, then The correct statement for the gas at low pressure. Now students, for real gas, we have potential energy also, right? Potential energy in the gas is like an attractive force. That's why potential energy will be negative here. That's why what you will see in the real gases, you will also take out the potential energy that is in negative, right? And in ideal gas, there is no potential energy that we assume, right? So that is why we will see that E ideal is more than E real, right? E ideal is more than E real. So answer will be A is the correct answer here, right? Answer will be A is the correct answer here. Next question students we have, consider a cyclic process P2Q, R2P, P2Q, Q2R, R2P for a system among the following combination of steps that are never led to the cyclic processes. Now, this is a very, very simple thing here. If you talk about P2Q, I'm just going to draw the cyclic process they are saying, right? It should not be cyclic process, it should be cyclic process. See, if you talk about adiabatic reversible, P2Q adiabatic reversible will be like this, right? Irreversible will be straight, reversible will be curved, right? Adiabatic reversible will be this. This is P, this is Q, this is R, right? Now understand one thing, whenever we talk about adiabatic reversible, you have to go in one direction, Q to R, then they are saying that R to P is adiabatic reversible. See one thing, no doubt they are asking you to go from R to P. But in case of adiabatic reversible, right, only in case of adiabatic reversible, it will retrace its path. Okay, the path will be the same here. The path will be the same here, and there is no cyclic process that is formed. Okay, there is no, because the path is going to be same. That is why there is no cyclic process that is formed here. So answer is going to be, they are asking you cyclic or acyclic, can never lead to cyclic process, right? That means A is the correct answer here. A is the correct answer here. That can never lead to cyclic process because the adiabatic reversible process will retrace its path, and hence cyclic process is not possible in that case, right? Okay. Next is hydrogenation of cyclohexene and benzene take place as shown below. The resonance energy is given to be. Now I know most of you will answer y is equals to 3x, but that is not the correct answer. I'll tell you why. See students, if you have one single bond, one double bond, and its energy is minus x, and you have three double bonds, its energy is going to be minus 3x, that is definitely right. But if we see these three bonds are in the benzene, these three bonds are in the benzene. In that case, there is also aromatic stability. Aromatic stability. So you have to break that stability also. It's not only the bonds you are breaking, you have to put energy to break the stability, and that's what they are saying. The resonance energy of benzene is minus 36. You have to kill this resonance energy as well. That means if I say that energy here is, let's say, the energy to break this bond is minus y. This minus y is equals to minus 3x. That means the energy that is needed to break three double bonds, right? Plus the energy that you will use for resonance energy. Resonance energy is minus 36. So answer will be y is equals to 3x plus 36, and answer is going to be y is equals to 3x plus 36. So answer is going to be B is the correct answer here. Okay, B is the correct answer here, right? Okay, so answer is going to be wait a minute, minus y, wait a minute, energy of resonance, the resonance energy, stability, wait a minute, this is the total Y energy, right? This will be the energy needed to break the 3 bonds. And you also have to prove, yes, I'm so sorry. Yes. Here, so sorry, sorry. Now I'll tell you what we did here. This is the energy release. Okay. This is the energy release. Right? So, when you break one double bond, the energy release is minus x. When you break 3 double bond, the energy release for 3 pi bonds, the energy release is minus 3 of x. So that means minus y, the amount of energy released in this aromatic 3 pi bonds is equals to energy released in 3 pi bonds, simple pi bonds, minus you have to give the energy required to break the resonance, right? That means to break the aromaticity resonance, right? So for that you will give it energy. That means that you will subtract here, and that's how answer will be y is equals to 3x plus minus. You can also get an idea that this will be subtracted, or best way is to understand that energy will be absorbed by the system to break the resonance stability that it already has, right? So that amount of energy you will have to take out. So answer will be y is equals to this. So answer, yes, it is going to be C is the correct answer. Y is equals to 3x minus 36. Next we have is, you have complexes COX6 3 negative, COY6 3 positive, and then COZ6 3 negative. Absorb this respectively. The ligands X, Y, Z are. Now see students, if you have energies, if you have to write the energy, they are saying this is X, Y, and Z. Energy lambda of which is maximum. Lambda of X is maximum, then Y, then you have Z. That means energy is inversely proportional to lambda. So energy of Z is maximum, then Y, then X you will have. Right? Now, they are saying which is the ligand. X is going to have least energy here. So can you see this here? Which particular option is correct one here? If you correlate with, if X is minus F negative, this is NH3, this is CN negative, this is the strongest, that is true, that is also true, that is also true. This is in accordance with the spectrochemical series. That means we can say this is the correct answer here, right? So A is going to be the correct answer here, right? Okay. Next question is, last 2 questions we are left with, right? So a homogeneous mixture of compounds PQR is spotted on a thin layer chromatography TLC plate, right? The TLC plate is made up of acidic silica. The spotted TLC plate is placed in a closed jar containing diethyl ether as a mobile phase. Now, beta, see this thing. Diethyl ether. Tell me this thing, is this polar or non-polar? This is non-polar, right? This is non-polar. That is the... So this is basically based on chromatography. You have a TLC plate here. TLC plate you have. TLC plate is made up of acidic silica. Okay. The spotted TLC plate is in a closed jar containing this ether. That means this is the mobile phase in the medium that you have. As the eluent rises up the TLC plate, the compounds of the mixture separate and travel to this distance. So they're talking about. See, one simple thing is that the one which is, because non-polar is going to attract the non-polar, like dissolves like. Okay, so that's why on the upwards you will have non-polar, right? Downward you will have more polar. That's it you need to know, right? We know that if you talk about the correct statements here, this is A, let's say this is B, this is C, this is D. The separation of compounds depend on the degree of adsorption. That is absolutely right. The more adsorption, right? That's how they are. The principle is degree of adsorption only, right? In chromatography, that is the correct statement. Next is the compound Q moves faster than compound P. If compound Q is moving more faster. That means it has to be more non-polar, right? Okay, this has to be polar. This has to be polar, right? So Q is this is P. P is polar. P, no, it is not polar, right? Q is non-polar as compared to, which is non-polar? Q is more non-polar, right? Q is more non-polar as compared to P. ठीक है? नहीं, ulta I am saying, sorry. Here mu is equals to 0, so it is being non-polar, right? So this is non-polar. P is non-polar. But here the opposite thing they are saying, so B will be incorrect only. Yes. B is incorrect. Okay, B is incorrect. Why? Because they are saying that Q is moving faster, so this should be non-polar, this should be polar. But in reality, we know that this is mu is equals to 0, right? It will cancel out each other. So we can see this is a non-polar species, right? So that means this is definitely not correct, right? Now, next is the compound R moves slower than compound P and Q. R slower means it is having high polarity. Polarity is greater than P and Q. Let's see whether polarity of R is greater than P and Q. This R is having nitrogen. P is definitely less polar, right? Because it is mu is 0, this is more polar. And with respect to Q also, it is more polar. Why? Because this is carbon. Carbon is less electronegative. This is more electronegative. So that's why definitely this is going to be more polar. It will provide more electronegativity difference. So it will going to be more polar. So that's why it moves slower as compared to P and Q. More polarity means it will remain here. It will not move upwards. Upward it moves because of the capillary action, right? So that means this is also true, right? Next is compound S. There is compound S is expected to move slower than the compound R. If compound S is slower, that means compound S is maximum polarity as compared to is expected to move slower than R. Compound, that means S should have even more polarity than compound R. Is it true? Yes. Why? Because here you have oxygen which is even more electronegative, right? This is electronegative. This thing is same in R and S, but this thing is differentiating, so that means it has even more polarity, so it will move even slower. So that means D statement is also correct. So answer is A, C and D. These three statements are the correct statements here, right? Let's see the next question here, right? This is the last question of today, guys, right? So in this question, what you have is, considering the following reaction, you have this is alkyl bromide, this is alcohol, and you are giving diethyl ether, and you are forming a ether here, right? Simple is, you have Rx, you have ROH, you have the formation of ROR, right? Now this reaction can be SN1 or SN2 depending upon the stability. If you see this here, if I proceed this via SN1 reaction, there will be formation of carbocation. If I see that carbocation is more stable here, if I see that carbocation is more stable here, then I can say that here you have the SN1 reaction. So can you see here you will have the formation of this carbocation, which is allylic carbocation, which is more stable. That means it will follow SN1 reaction. Okay. In SN1 reaction, this is based on the rates. Okay. So in SN1 reaction, we know that rate is directly proportional to K, and this is nucleophile or what? This is only the substrate. That means you will write Rx, that's it. Because here it is in SN1 reaction, it is not dependent upon the nucleophile. Nucleophile will come in the second step. In the slowest step, you only have the substrate, right? You only have the alkyl halide, or in this case, allyl halide, right? That means it will only depend upon allyl halide. So this is A, this is B, this is C, this is D. Let's see this here. If the concentration of allyl bromide is doubled, then the rate of reaction is doubled. If this is doubled, rate of reaction will double. Is it true? Yes, because they are directly proportional. If this doubles, this will also double. That is true. If the concentration of ethanol is double, this ethanol, this will generate the nucleophile. Now, if it is double, there is no relation only, right? Because in the rate of reaction equation, it is not related to alcohol. If the concentration of allyl bromide and ethanol both are double, the rate of reaction is quadruple. That means if you say this is doubled and this is also doubled, 2 of OH, you can say, only then it will be double. That means in the rate of reaction, it should be dependent upon the alcohol also. But this is not there in the reaction, so this is also ruled out. Last is if the concentration of allyl bromide and ethanol is doubled, rate of reaction is doubled only. That means even if I double this, this will be double. Even if I am doubling ethanol, because it is not dependent upon the rate, so that means it will be doubled only. So this is the correct thing. So that means A and D are correct here. E and D are correct here. And that's it. Okay, students. So rest 3 questions I am giving you for homework. Solutions are already there in the those 3 questions that I am giving you for homework. Solutions I have already given you along with it. Right? 3 questions for homework, solutions with that. Now for all the JEE 2027 aspirants, guys, we have this batch, that is Sigma batch, in which live classes we are doing right now, right? And in the live classes, there is proper doubt solving, quizzes, leaderboards, everything is there. And even we provide you one Tattva modules in which we solve the questions in the class, and we also give you some questions for homework, right? So that you can practice on your own as well. We also tick the questions that were the questions that you should do for homework. Now, DPPs, ma'am, will they be provided? Yes, definitely they will be provided. Next question is, ma'am, will mock test will be provided? Mock test will be provided because every 15 days we'll take the mock test of what the syllabus that we have completed in the batch, right? And this batch, the price is just 3,999 and it is going to start from 29th of May, right? Even now the students have already enrolled and the classes have started, but we know that students sometimes students get late in starting their journey, so that's why we have this new entry point where you can definitely join from 29th of May as well. There will be no backlogs that will be left, right? But for that, what you need to do, for that you have to join here, right? Otherwise again there will be backlogs that will be created, right? After a month or so it will be very difficult to complete those backlogs, right? Already this batch is for class 12th and droppers, so already there will be so many backlogs. I don't want you to create more of them, right? So enroll to this batch right now. Only the link is in the description, as you can see, right? In the description you have the link, right? Sigma JEE batch 2026. Click on this and here you have the link, right? Okay, and that is the rate, everything is mentioned here, right? Okay then students, now I'll take your leave. Bye bye, take care. And I'll want to, this is our official Telegram channel of JEE, right? You can always subscribe to this so that you can get notified whenever we go live here. Okay then students, bye bye, take care.